this project's all about trying to understand how the effects of microgravity is impacting how beneficial microbes and animals talk to each other. We're sending these tiny squid into space to understand how the bacteria are actually colonizing and initiating a conversation at the molecular level. When they're born without bacteria. And so when they flew before, we learned that even in microgravity, you can have your proper symbionts, your beneficial microbes, find where they're supposed to go. We're going again and looking at a little bit more deeper questions about the actual processes, the fundamental processes of how the bacteria are starting a conversation with the animal tissues. So we're building on those previous experiments from 10 years ago.
The RamSat is a CubeSat sent up by Robertsville Middle School in Oak Ridge, Tennessee. This will be one of the first satellites ever to be sent up by a public middle school.
So the mission of our satellite is that we're looking at the regrowth of wildfires in Gatlinburg in California.
So we created this satellite with scientists from our national lab.
In this clip, you can see we're putting the solar panels on, and this specifically is where we're soldering the wires together.
So along with our mission of tracking the forest fire regrowth, we also hope to build curriculum for other middle schools and schools around the globe to create satellites and become more invested in space, like all of our students are.
Our project is looking at how these tiny little microscopic animals called water bears or tardigrades are able to cope with the stresses of long-term spaceflight. And we're using these animals because they're some of the toughest animals that we know of. They can survive being dried out, frozen, heated up past the boiling point of water. They can survive thousands of times as much radiation as you or I can, and they can survive spaceflight and even exposure to the vacuum of outer space. The sort of two main stressors during spaceflight are microgravity and increased radiation. So we'll be looking to see what genes, what parts of the animal's DNA they're turning on and off. And so by understanding how these really tough little tardigrades are able to survive in those conditions, we're hoping to be able to develop strategies or countermeasures to safeguard astronauts from those stresses.